Hi everyone and welcome to my channel. My name is Shamui and I'm going to teach basic chemistry in this channel. I'm starting this channel because I want to share my understanding of chemistry with students, and I know that many students struggle with understanding chemistry concept. I hope this video will help students who are facing the same problem that I did. I will be creating video on a variety of topics from basic chemistry concept. This channel will remain independent, so if you like what I'm doing and want to see more videos, I would really appreciate your support. The best way to support me is to subscribe to my channel and leave me feedback on my videos. Thank you for watching and I hope you enjoy my video. In this video, we will be exploring the three major theories that defines acid and base: the Arenus theory, the Brownsted and lowery concept, the Lewis theory. Understanding this concept will grasp the behavior of acid and base in various chemical reactions. Before going to the concept of Arenus theory, Brownsted theory and then Lewis theory, here we will discuss some properties of acid and base. So the property of acid, the first property of acid is acid have a sour taste, and acid is not slippery. The other property is acid have a pH value less than 7 on the pH scale. Now you take an example of acid, lemon juice. This lemon juice, what is the taste of lemon juice? It is sour in taste, right? So this is the character of acid, one character property. And then it is not slippery. You won't find it slippery. Lemon juice will not be slippery. So that is one property. And then pH value will be the pH value of acid will be less than 7. 1, 2, 3, 4, 5, 6 till that acid will show its pH value less than 7. And then property of base is base have a bitter taste. Just take an example of soap solution. So soap solution is bitter in taste, but don't try this at home. Just taking the example of soap solutions, you don't need to try. It's bitter in taste. Base have a slippery or soapy feel, and then base have a pH value greater than 7 on the pH scale. pH scale, we have pH scale. Now here this is 7, 6, 5, 4, 3, 2, 1, 0. Just like that it will go on. So all those these value smaller than 7 will be acidic, and then pH value greater than 7, which is 7 is neutral, so which is greater than 7 will be base. Now another property of acid is acid turn blue lambda's paper red, indicate blue lambda's paper red, indicating their acid nature. Now just see, this is blue lambda's paper. When you put this blue lambda's paper into acid solution, this is acid solution. If we put, then it will turn into red. While base turn red lambda's paper blue, indicating their base nature. When you put this red lambda's paper into base solution, then it will turn into blue color. That is the property of base. And then another property of acid is acid can conduct electricity when dissolved in water due to the presence of iron. Acid solution will contain iron, so when you dissolve in water, it will conduct electricity. The same goes with the base. Base can conduct electricity when dissolved in water due to the presence of ion. Both acid and base, when you dissolve in water, uh, it will conduct electricity. Now another property of acid is acid react with base to form salt and water through a neutralization reaction. When you put acid and when you react acid and base, it will form salt and then water. The same goes with the base. When it react with acid to form salt and water through a neutralization reactions. When acid and base comes together, it will neutralize each other. Like acid strength will be less and then base will be less. So if these two react, then it will form salt and water. Now strong acids such as hydrochloric acid HCl and sulfuric acid H2SO4 dissociate completely in water, while weak acid only partially dissociate. Strong acid, when we dis when we when we completely dissociate, it will completely dissociate, but weak acid uh, weak acid will only partially dissociate. Strong base such as sodium hydroxide NaOH and potassium hydroxide KOH dissociate completely in water. When you put base solutions in water like KOH and NaOH, it will dissociate into Na and OH and then Ko and OH. So it will dissociate into different ions. But when you put weak acid, weak base, then it will dissociate only partial, not completely. So some example of acid are like naturally occurring acid are like citric acid, which we found in lemon and orange. Acetic acid we found in vinegar. Tartaric acid, grapes and fruits. We will find this tartaric acid in grapes and fruits. And absorbic acid, various fruits and vegetables. We can find it in fruits and vegetables. Now example of base. Example of common base include baking soda. Baking soda which we use in our kitchen for making some biscuit and all, which we used. And then its chemical name is sodium bicarbonate. And ammonia NH3 and acids calcium carbonate. These are example of base. Ammonia, especially base, are used for cleaning products like soap and then toothpaste and all. You will find base which is used. Now let's go to Arenus theory concept. The Arenus theory of acid and base was proposed by Swedish chemist Wendy Arenus in 1884. According to this theory, now we will describe acid and base based on how Arenus has described. Acid are substances that dissociate in water to produce hydrogen ion. So, according to Arenus, acid are substances when you put acid into water, then it should produce hydrogen ion. If any substance put inside the water and if it dissociates into hydrogen ion, then it is acid. Whereas base are substances that dissociate in water to produce hydroxide ion OH. So any substance when you put inside the water and if it produces OH ion means it is a base according to Arenus. When acid dissolves in water, it releases hydrogen ion, which can then react with water molecules to form hydronium ions. Now, what is the chemical formula of water? It's 2O. So, when you put acid in the, according to Arenus, acid will dissociate, acid will produce hydrogen ion. So those which acid will produce hydrogen ion, it will react with hydrogen water molecules, and then it will form into H3. It was H2O, now it will become H3. If you add one more hydrogen, then it will become hydronium ion. Whereas base dissolved in water, it releases OH ion, which can then react with hydronium ions to form water molecules. So again, if you this base, when you put into, when base is dissolved in water, say this hydronium ion has one more hydrogen atoms, hydrogen ion. So when you put base in the solutions, it will produce OH ion. So if you put one H here, then H2O, which is water molecules, nothing but water molecules. Now example of Arenus theory: hydrochloric acid HCl dissolved in water to produce hydrogen and chloride ions. So this is the example of Arenus acid. So like here, HCl plus H, when dissolved in water, it will give H plus and Cl plus and water. H2O is a natural substance that does not produce hydrogen or OH ion, but water will not produce any ion. And then it is important to note that the Arenus theory is limited to aqueous solutions and does not explain the behavior of acid and base in non-aqueous solvent or in the absence of water. But we cannot apply. This is the limitations of Arenus theory. It is based only on aqueous in presence of water, because when we are putting inside the water, hydrogen ion produced means acid, and OH ion produced means water. So without aqueous solutions, we cannot predict the acid and base property according to this theory. Now we'll go to the concept Bronsted-Lowry theory. Bronsted and English chemist Thomas Lowry in 1923. According to this theory, an acid is a substance that donates a proton, H plus, to another substance during a chemical reaction. So according to this Bronsted-Lowry theory, acid as substance, it will donate hydrogen plus to another substance. When you make a reactions, if the reactant or substance, any substance, if it donate its proton to another substance, then it is acid, while base is a substance that accept a proton. So opposite to that, base a substance which will accept proton during reaction. Okay, the acid base reaction involves the transfer of a proton from the acid donor, acid is a donor, to the base acceptor, forming a conjugated acid and a conjugated base. So when these reactions, like when acid donate proton and then base accept proton, those product will be like conjugated acid and conjugated base. In a reaction between an acid and a base, the acid loses a proton to the base, resulting in the formation of new acid and a new base. Now when the product is formed, it will result in the formations of new acid, which is conjugated acid and conjugated base, new base. Two products will be formed when acid and base react. Example of Bronsted-Lowry theory: acetic acid C3CO, which donate a proton to water, which acts as the base. Now here, see, this is acid. Acetic acid is an acid. If it's react with water, it will donate its hydrogen ion to its proton to water. So here acetic acid will act as an acid, and then base this water act as a base. It will accept. In these reactions, water accept the proton from acid and forming hydrogen ions, H plus. Now we will go to Lewis's theory, proposed by American chemists Gilbert and Lewis in 1923. An acid is a substance that can accept a pair of electron pair acceptor. We also call electron pair acceptor Lewis acid. Any substance can which accept pair of electron, that is considered as Lewis acid. Whereas a base is a substance that can donate a pair of electron, opposite to acid. Electron pair donor, it will donate. Base is a substance which donate pair of electron to any other substance. The acid-base reaction involves the donations of electron pair from the base to the acid, forming a coordinate covalent bond. So these acid-base reactions, acid will accept, and then base will donate electron pair of electron, so it will form a covalent bond between them. Lewis acid can be neutral molecules, ions, or even compound without a proton. So here Lewis acid can be neutral molecules. It can be neutral or ions or even compound without a proton, because it has to accept pair of electron, as they are characterized by the ability to accept an electron pair. See, since acid is a characteristic which can accept pair of electron, it might be a molecule, ion, or even a compound. Example, proton trifluoride PF3 act as an acid. This will act as an acid by accepting a lone pair of electron from ammonia. When this BF3 and then ammonia is react, BF3 and H3, in these reactions ammonia donate a lone pair of electron to proton trifluoride, forming a new compound. This BF3 and H3 will be formed. It will form a coordinate covalent bond between BF3 and NH3. So we'll go for summary now. Arenus theory. What is Arenus theory of acid and base means? Now we will summarize again. Acid as substance that produce hydrogen ion. Arenus theory, in presence of water, when you put some substance to the water, if it produces hydrogen ion, means it is a base. And when any substance, when you put inside the water, if it produces OH ion, then it is considered as base, according to Arenus. That's you have to remember. And then Brownsted-Lowery theory focus on the transfer of proton. Now here, acid donate proton and base accept proton. Okay, acid will donate proton and base will accept proton. Now we will go to Lewis theory. Acids are electron pair acceptor, and then base are electron pair donor. I hope you have understood the things. So understanding the acid, the Arenus theory, Brownsted theory, and Lewis acid-base theory is crucial for comprehending the behavior of acid and base in the chemistry. This theory will provide different perspectives of acid-base interactions and help us explain various chemical reactions. Remember, acid and base play a vital role in our everyday life and in the world of chemistry. Keep exploring and learning. I will see you next time. Thank you for watching.